So inequalities applied to absolute value functions is when an inequality sign is involved and an absolute value function is involved. And this topic is often considered a subtopic of inequalities applied to quadratic functions, since the concept applied is the same. We'll take three examples, and the first example is this. So, in order to remove the modulus, we'll have to square both sides. And I repeat, in order to remove the modulus, not cancel the modulus. So the square means. Now apply the identity. So we have 9x squared minus 12x plus 4 is greater than equals to 4x squared plus 4x plus 1. Take everything to one side. So we'll be left with 5x squared minus 12 minus 4 is 16. So we have minus 16x and a plus 3 is greater than equals to 0. So now we have a quadratic inequality. So the first step will be to find the roots. So break the middle term as minus 15x and minus x. Take 5x common, you'll be left with x minus 3. Take minus uncommon and you'll again be left with x minus 3. The factors turn out to be 5x minus 1 and x minus 3. The roots turn out to be 1 over 5 and 3. So after finding the roots, we'll have to draw the graph, which would look something like this. We have 1 over 5 here and 3 here. We look at the sign of the inequality, which is greater than equals to. So the region required is above the x-axis. We'll shade that. And when it comes to leaving our answer, it will be x is less than equals to 1 over 5 and x is greater than equals to this one. And then our second example. Let's take an expression on one side and a constant on the other side. For example, 2x minus 1 and is less than. So in order to solve this, we have two methods. The first is the plus minus technique and the second is squaring both sides. So method 1 is writing this as minus 7 is less than equals to 2x minus 1 is less than equals to 7. So we'll break this into two parts like this and we'll make a column, two columns rather. So we have minus 7 is less than equals to 2x minus 1 and this turns out to be 2x here and minus 6 here. So we have x is greater than equals to minus 3. And then following the second part of the inequality, we have 2x minus 1 is less than equals to 7. We can write this as 2x is less than equals to 8 and x turns out to be less than equals to 4. So our answer turns out to be x is less than equals to 4 and minus 3 is less than equals to 3. And if we use the second method, the sequence will be something like this. So we have 2x minus 1 modulus is less than equals to 7. We square both sides to remove the modulus from the left hand side and apply the identity to expand the bracket. So we have 4x square minus 4x plus 1 is less than equals to 49. Simplifying this would give us 4x square minus 4x minus 48. We can take 4 common and further simplify this. So we have x square minus 4x plus minus x rather minus square is less than equals to 0. We can break the middle term like this and take x common. So we have x minus 4. Take 3 common from here and we have x minus 4 yet again is less than equals to 0. These are our factors and we have two roots. Now, since we solve a quadratic inequality, we'll have to draw the graph, which would look something like this. Hence, the answer turns out to be x lies between 4 and minus 2. This is because the region below the x-axis was required, and appreciate the fact that this answer matches with this. And so, we'll take our last and final example. Let's take expressions on both sides. But modulus only on us. So, so first of all, let's recap. Whenever we have expressions on both sides, but a modulus only on one side, we must check the answers obtained. I repeat, whenever we have expressions on both sides, but a modulus only on one side, we must check both the answers obtained to check if one of them is rejected or not. And in this example, we'll have to do the same thing. That is, check both the answers obtained. So we'll start off by squaring both sides. And whenever we square both sides, we remove the modulus, not cancel the modulus. So the square still remains and we apply the identity to expand, and we have 9x square minus 12x plus 4 is less than equals to 4x square plus 4x plus 1. We take everything to one side and we get 5x square minus 16x plus 3 is less than equals to 0. We break the middle term so we can find the roots, and we have minus 15x and minus 16 and minus x. Take 5x common and we'll be left with x minus 3. Take minus 1 common and we'll be left with x minus 3 yet again. And the two factors turn out to be 5x minus 1 and x minus 3. And thus the two roots turn out to be 1 over 5 and 3. Now the next step would be to check the validity of the answers. This is a very important step. So we check the validity by substituting both values back to the original equation. In this case, both the values satisfy the inequality and thus we'll accept both the values. Both 1 over 5 and 3 will be accepted. The next step is then drawing the graph. First of all, make the grid and then make the typical shape of a quadratic graph and indicate the roots, the solutions of the graph. The sign is less than equals to, and thus the region below the x-axis is required and shade that region. And our final inequality turns out to be x lies between 1 over 5 and 3. And this is our final answer.